We're going to continue on with our angle measurement, more specifically. The gentleman in the angle basics video told you that we measure angles in degrees. Yeah, later on in high school you'll use radians, but for right now we use the term degrees to denote or tell how big or small an angle is. Just as we can compare two people that one person is shorter or taller than another, really doesn't tell us how much shorter or taller. So just as the gentleman said, we could draw an angle, this little angle here, okay, and say it is less open than this angle, okay. Okay, and we could, or this is more open than that, but it really doesn't tell us specifically what is this measurement. And he also told you that the convention, or what it comes from, is a circle, and that they took a circle and they took that circle, and they basically took that circle and divided it into 360 turns, equal turns, that is. So let me show you exactly, and this is why I wanted to do this. I can show exactly with this specific type of protractor. We can put this right here in our circle. And you see, as we go around the circle, that the circle has been divided. All these little tick marks here, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and we're using the inside set of numbers because our 0 starts here. Okay, going this way. If we're going the opposite direction, we would use the outside, but I'm going from this way, so we always start counting at 0. This is where our baseline is. So you can see that this circle, now you can see the 360 as you couldn't see in the last video. You can see that this whole circle, as we go all the way around, starting here, you can see we're moving in these little tick marks. I'm now at 20. I moved 20 of those degrees. So if I were going to draw this angle for 20 degrees, and this is the nice thing about this, is I can move this up to 20. You can see I've moved that where it's right on the 20, and I'm going to, so there's my 20 degree angle, because this has turned 20 degrees from 0 to here. If I were to continue on, I could keep going, and now I could go up to that one that we're familiar with, which is, this is a 90 degree angle. Let me move this 20 degree down here. This is a 90 degree angle, or we could call this a right angle because it is 90 degrees. It makes that perfect square corner here, okay, which is our notation. So this is our right 90, and we can describe these. Yes, we know this is more open than this, but now we exactly know. So this measurement, this angle is 90 degrees. This measure, so now we know this is open 70 degrees more than this. And we can continue doing this. We can continue moving and making different angles. We can go make an obtuse angle, okay, which is 150 degrees, and I'll put that over here. If I can get a little more room here, let me slide this down over here. So that's 150 degrees, and you can see that this angle, and that's why we do the arc, because we're moving in a circle as we turn this angle. So this is 150 degrees, and that is certainly a lot more open than 20 degrees, and even more open than 90 degrees. Now what you have to realize is that we can even go past this. Of course, that's our straight angle, but we can even keep going. So now we have moved on this, turned on this circle 220 degrees. We're still using the inside because we're still moving from this way to this way. Remember, that's what you have to be careful of and we'll talk about that more when we use a protractor. We're moving from this way to this way, so this would be the angle that we're talking about here. It's even more open. So what should you take from this? This is important to know that our angles come from dividing up a circle into 360 parts. So we could say that a 1 degree angle, okay, and let's show that. That's a 1 degree angle. Oh, that's not what I wanted there. It's 219. I've moved it back. So let me move it back. So, oh, it went to 0. Hold on. Oh, I don't want a 0 degree angle. There we go. So there, as you can see, that is a 1 degree angle right here. So if I were going to make this complete circle, how many 1 degree angles would it take to go all the way around? That's right. It would take 360. It would take 360 of these to make that complete turn, full circle turn. Okay, 360 of those 1 degree. Now, with that being said, how many? Okay, and let me get a new page. How many? Oh, sorry about that. Got the wrong thing. How many of the 90 degree turns, 90 degrees, would it take to go full circle? Think about that now. How many 90 degrees? All right, well, let's take a look. Well, if 90 degrees takes us from here to there, all right, we haven't gone all the way around. So if we let's flip this so we can okay, and I'm going to turn it so now I can place another 90 degree right there. So now we've gone from here to here. So that's 2. So let's take another one of those and turn it so we can place it in the next. So now we have gone this far around. So now let's put another color in. So we've gone from here to there. So that's 1, 2, 3. You can see the different colors. And then, of course, I think you can see this last one here. And let's make that black. And so now, how many? Okay. How many did it take? So now let's see. I'm going to remove my circle. So how many 90 degree turns did it take to make that? We can see, and we can draw this. I didn't put that last one in. If I do that, let me do that so you can see all of them in here. So if I take this last one and I turn it, okay. So now let me take away that, and you can see that it took 1, 2, 3, 4. It took 4 90 degree turns. So, or right turns, right angles, excuse me, right angles to make that circle. So we could say that since it took 4 of those, then then each 90-degree turn is 1/4 of all the way around. So each one is 1/4 all the way around. Ooh. I can do better than that. So each one is 1/4 all the way around. So 2 would be 2/4, 3 right angles would be 3/4, and of course all the way around would be 4/4. Okay, make sure that you write down any questions about any misunderstandings you may have.